Let's look at some more here. A few more examples to give us more practice. Okay. Is this a redox reaction? Immediately you know it has to be, because you see that elemental nitrogen, 0 oxidation number. Over here it is in a compound, so let's look at its oxidation number. Okay. Hydrogen, always +1 when it's in a compound. All right. Now this is an interesting situation here, because you're saying, well, where's, they come in pairs, right? And here I've already eliminated my hydrogen, it's +1. So what's going on here? Well, let's look at this and we'll see that the nitrogen here, we have +4 from the 4 hydrogen atoms, and that's divided among between 2 nitrogen atoms. So each of these must be a -2, right? -2, -2, that gives me -4 to balance the +4, right? So the nitrogen is a -2 and goes to 0. So that would be oxidation, but where's the reduction? Well, there's nitrogen over here as well, and you see that this one, +1 times 3 is +3. Here it's a -3. So in this case, it's the nitrogen that is oxidized and the nitrogen that is reduced. And the hydrogen just kind of stays the same, right? But the nitrogen is oxidized to the nitrogen gas, and it's reduced to the ammonia at the same time. All right. Now, what's the oxidizing agent and what's the reducing agent? Okay, this is a unique example, but there's only one substance here that we're reacting, right? So it serves both as its own oxidizing agent as well as the reducing agent. Okay, a little bit different reaction, but just to show you a little bit of the variety, we'll look at some of the more unique ones here. Right. So this is both the oxidizing as well as the reducing agent. Okay. Again, the agent is referring to the whole compound, so it's not the hydrogen that's reducing or oxidizing the nitrogen. Okay, you might say that the hydrogen is reducing the nitrogen, but it's certainly not oxidizing it. Okay, so it's the whole substance is serving as its own oxidizing and reducing agent. That's the best way, I think, to look at that. Okay, now here we have another reaction, and we ask ourselves, is this a redox reaction? We have carbon in its elemental form here and in a compound over here, so we know, yes, indeed, it is a redox reaction. So let's look at this and determine what the oxidation numbers are. Okay, so carbon goes from 0 to, well, let's see, I'm not sure about this one yet, but I know my oxygen is a -2, so my carbon must be +2, right? Oxygen over here is a -2, so my silicon must be +4, right, to balance the two -2s. Okay, so I see that my carbon is going to 0 to 2. So see, the thing with this one is I don't have carbon, I don't have oxygen, I don't have hydrogen, so I'm not entirely sure which one of these, and it's not an ionic compound, we have two nonmetals here, a metalloid and a nonmetal, so it's not an ionic compound, so I can't go by the charges, and I don't have oxygen or hydrogen as a reference. So let's see if we can determine this another way. And here, first of all, I know that carbon is being oxidized, right? So carbon is my oxidized element. That means, and oxygen is not being oxidized or reduced. So it must be, or at least silicon is a good bet that it's being, it is our reduced element, okay? But it's not necessarily the case, because in fact I think we can see that it is not, because carbon, just like in this example, the same element can be reduced as well as oxidized, okay? And here we have carbon in this compound as well as over here, so it's going from 0 to positive 2, it's being oxidized, 0 to, well, if the silicon stayed at positive 4, this would be going 0 to negative 4, right? And I think that would be our best way to look at this. The only other option would be for the silicon to go from, you know, I mean, we really don't have any other reference for silicon. What should carbon be other than, you know, leaving silicon at that +4 and making the carbon a -4, okay? And then that becomes our reference to determine the silicon. But if you know, our carbon is certainly not 0 in this compound, because if it were 0, then silicon would be 0, and anyway. So I think this is the best way to look at that. We would have the silicon as a +4. We just keep it at a +4. There's no reason to change it. And then the carbon itself is both oxidized and reduced. Okay, hopefully that makes some sense there. And what is the oxidizing agent? Well, what caused the carbon to be oxidized to carbon monoxide? The silicon dioxide, okay? So this is our oxidizing agent. And what's the reducing agent? What caused the reduction of the carbon from 0 to -4? Well, also the silicon dioxide. So it's the oxidizing as well as the reducing agent. Again, these are not your typical examples. These ones are a little bit more unusual, I suppose you would say. Having the same element as the oxidizing and reducing agent is not typical, but just to show you that it does happen, and we'll see a couple other strange things or unusual things with some of these in a minute. All right, but you go through the process, and you know, here we kind of have to make a little bit of a judgment call, but I think this is a reasonable assumption to make, that the silicon is going to remain a +4. Okay, let's look at this one, and we have hydrogen in a compound is +1. Okay, over here still in a compound +1. All right, the oxygen, oh, here it's going from 0 to -2 in both cases. All right, so we know the oxygen is participating, it is being reduced. Okay, so there's my reduced element. And what is being oxidized? Well, the carbon over here, you have +4, so the carbon is going from -4 to, what is it here? The oxygen is -2, so this must be +4. So it goes from -4 to +4. That's an increase in the oxidation number. It is being oxidized. Okay. What is the oxidizing agent? Again, whenever you have that elemental oxygen, that's a good bet. It is the oxidizing agent. That is what is oxidizing the carbon. Okay. And the CH4, the methane, this is my reducing agent. That's what's reducing the well, I take that back. We look at this, and the carbon is going from -4 to a +4, okay? And so we have it's being oxidized, so it's being oxidized by the oxygen, okay? And yes, I am correct here in saying this. The methane is the reducing agent. It's reducing the oxygen from 0 to -2. Okay, so this one is more typical than the other ones that we're looking at here. All right. A couple more that we'll look at. Again, both of these are combustion reactions. All three of these are combustion reactions, reacting an organic fuel with oxygen to produce carbon dioxide and water. Okay, so these are always going to be oxidation reduction reactions. Okay, and the oxygen is the oxidizing agent in each of these cases, and it is the element that is being reduced, going from 0 to -2. Okay, so we'll just kind of look at these a little bit simultaneously. All right, but here we have the hydrogen is remaining in a compound, so it stays as +1. Okay? And carbon dioxide is a +4, like we've seen before, two of those -2s, so it balances with a +4. +4 in carbon dioxide. Again, the coefficients make no difference when we're talking about oxidation numbers. We're just looking at the molecules. Okay, so what is the carbon over here? Let's just look at this one first. Well, we know that altogether this has to add up to the charge, which is 0, because it's a neutral molecule. So my oxygen is -2, and I have two hydrogens, each one is a +1. Okay, so +2, -2, that balance out to 0, right? So, seems a little strange, but the carbon is also 0. And we see that it does indeed get oxidized, and the oxygen is reduced. Okay, so don't be put off by some strange things once in a while, particularly with these combustion reactions. When you get into higher numbers like this, let's look at what the oxidation number of carbon is here. Here we have +6 from my 6 hydrogen atoms. Each one is a +1. Okay, and that is canceled out by 4 carbon atoms. Okay, so if you did a little bit of algebra, you could say I have 4 carbon atoms, okay, and 6 hydrogen atoms. Each hydrogen is a +1, right? And that balances out to 0. So that means my 4 carbon atoms, if I take this 6 and subtract it, is -6. Or in other words, my carbon oxidation number is -6 over 4, or -3/2, -1.5. All right. So again, a little bit unusual. We can have fractional oxidation numbers, and you see that particularly with these combustion reactions. When you start seeing higher numbers there, you can get into some stranger-looking oxidation numbers. But that's what we would go with, and it fits the theme where oxygen is being reduced, and here we're going from a -3/2 to +4, so that is being oxidized. Still fits the pairing up of the oxidation and reduction in the reaction. Okay. Now let's look at the oxidizing agent and reducing agent. And this is the case in any combustion reaction. Oxygen is always going to be your oxidizing agent. Okay. In both of these cases, that's your oxidizing agent, the oxygen. And the fuel is your reducing agent. Okay. So, and because it's the fuel that is responsible for reducing the oxygen from 0 to -2, and it's the oxygen that's responsible for oxidizing the carbon from, in this case, -3/2 to 4, in this case, from 0 to 4. Okay, so this is my reducing agent. All right, so some unusual examples here. This would be more, this one really wasn't too unusual there, but the other 4 that we looked at on this one, a bit unusual, a bit more advanced, but that might give you some help in understanding the principles. You see, we followed the same principles, and we just kind of, that's the conclusion we came to, okay? Following all the same rules, the carbon, or rather the oxygen, being a -2 whenever it's combined in a compound, hydrogen +1, and sometimes, just be aware that don't feel like you're wrong because you get some funny answer like that. Just verify that you did it correctly. You're calling these -2. You've balanced it with the right number of atoms or whatever. And if that's the answer, that is correct. Okay, so don't feel like it always has to fit a rigid system, because that's more typical. There are some unusual ones as well, like having a 0 even though it's in a compound. But more typically, we see the ones like we did in the previous list there. These ones would be more typical. All right, I hope this has been helpful in your practice of oxidation numbers.